Thermodynamics is a branch of physics that deals with the transformation and distribution of energy within systems. It plays a central role in many fields of science and technology as it describes fundamental principles that govern the behavior of energy and matter. Main laws of thermodynamics. There are four main laws of thermodynamics that form the foundation for understanding this field. Zeroth law of thermodynamics: if two systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. This means that the temperature is uniform throughout if no energy exchange occurs. First law of thermodynamics, law of energy conservation: energy can neither be created nor destroyed, it can only be transformed from one form to another. This is the principle of energy conservation. For example, in an electric stove, electrical energy is converted into heat energy, which is used for cooking. Second law of thermodynamics: heat flows from a hotter to a cooler object and not in the reverse direction unless additional energy is supplied. This means that the entropy, a measure of disorder in a system, always increases in a closed system. An example is an ice cube melting in a warm room. Third law of thermodynamics: it is impossible to reach absolute zero, 0 Kelvin, because the entropy of a system would be zero at this point, which is practically unattainable. Importance of thermodynamics. Thermodynamics is crucial for understanding many natural and technical processes. It helps explain how engines work, how cooling systems operate, biological processes, and even weather patterns. The principles of thermodynamics are also vital in developing new technologies and improving energy efficiency. Law of energy conservation. The law of energy conservation, also known as the first law of thermodynamics, states that the total energy in a closed system remains constant. Energy can be transformed but not created or destroyed. A practical example is a light bulb, where electrical energy is converted into light and heat energy. Symmetry in physics. Symmetry in physics often means that physical laws remain unchanged under certain transformations. An important symmetry is time translation, which means that the laws of physics are the same at different times. This symmetry is closely related to the law of energy conservation as it implies that the total energy of a closed system remains constant over time. 1. By understanding these fundamental principles of thermodynamics, we can better comprehend how our universe functions and develop technologies based on these principles. 2. Blackbody radiation and thermodynamics, a simple explanation. What is blackbody radiation? Imagine a perfect oven that absorbs all light, and any kind of radiation that hits it. It reflects nothing, and everything that goes in stays inside. This is called a blackbody. When this oven is heated, it starts to emit radiation in the most efficient way possible. This radiation is known as blackbody radiation. Properties of a blackbody. A blackbody is a theoretical concept that doesn't exist in reality but is very useful for explaining certain physical phenomena. The two main properties are: perfect absorption: a blackbody absorbs all types of radiation completely, without reflecting or transmitting anything. Perfect emission: when heated, a blackbody emits the maximum amount of energy possible for its temperature. What does the radiation spectrum look like? The way a blackbody emits radiation depends only on its temperature. As the oven gets hotter, the color of the radiation changes. For example, a hot oven will first emit red light, then yellow, and finally, if it gets very hot, blue light. Connection to thermodynamics. Blackbody radiation is closely related to the laws of thermodynamics. First law of thermodynamics: energy conservation: the energy absorbed by a blackbody is emitted as radiation. This keeps the total energy constant. Second law of thermodynamics: This law states that heat always flows from a warmer to a cooler object. In terms of blackbody radiation, it means that a hot blackbody emits energy until it reaches equilibrium with its surroundings. Practical importance: blackbody radiation helps us understand many natural and technological processes. For example, astronomy, stars behave similarly to blackbodies. Their radiation gives us information about their temperature and composition. Technology, infrared cameras use principles of blackbody radiation to create thermal images. Energy efficiency, solar panels are designed to absorb as much solar radiation, which is similar to blackbody radiation, as possible. Conclusion: blackbody radiation is a fascinating concept that helps us understand the fundamentals of energy transformation and radiation. It shows how closely linked various areas of physics are and how important thermodynamic principles are in our daily lives and technology.